Welcome back to the MS Portfolio. This is episode number 5, Take 7 million. Today we are covering Pascal's triangle, which is a little bit difficult to explain, which is why I'm on Take 7 million. That's real, by the way. Here we just have an example of what a Pascal's triangle expansion may look like. And here we have a bit of a better example. So here we have a plus 2b in brackets to the 6th power. Now, to expand using the Pascal's triangle, we begin by putting all of this power onto this first term, which gives us a to the 6th plus 12a to the 5th b, which means that we move a little bit of this power over onto this second term. And we're also multiplying by 6 because we're on the second term. So you get 2 multiplied by 6 gives us 12, and we're moving a little bit of the power over from this first term to the second. So we have 12a to the 5th b. And for this next term, I expanded it a little bit more just to show something that's going on here and make sure that you don't miss it. So when we move over, again, power from this first term into our second term, we get 2 squared times 15a to the 4th b to the second. And the reason that this 2 is to the second is because when we move our power over, we need to make sure that it's being distributed and that both parts of this term are both getting that power. Otherwise, we wouldn't get the right number. It would be a little bit smaller, and that's not what we want. So that leaves us with 60a to the 4th b squared. As you can see, this is what you expect to see. It's the same as this one up here, where the numbers get bigger and bigger and bigger, and then smaller again. Here we have a bit more of a sleek and smaller solution. Here, the first term is color-coded with red and the second with blue. And then we have our Pascal's multiplication here in pink. So again, for the first term, we multiply by 1, and then we have 3 to the 3rd rather, because all of that weight goes here. And then for the second term, we multiply by 3 because we're moving along based on which term we're on. And so we have 3 times 3 to the second times 3x. Again, moving this power over to the second term, plus 3 again, multiplied by 3 times 3 squared x squared. I wanted to emphasize this, although you could simply write it like this. I wanted to write it the way I did, just to really emphasize that this 3 is also being squared. And then that is multiplied again, this is supposed to be a plus 1 times 3 to the 0, which is just 1, times 3 to the 3rd x to the 3rd. And that leaves us with 27 plus 81x plus 81x squared plus 27x cubed. And we have one more example here, and this is our Pascal's x to the 5th right here. So our first term is root 2 to the 5th times 3 to the 0, root 3 to the 0, plus 5, and it's the same thing that we just did, only with radicals, and at the end, we add them all up and collect like terms.